We are still in Module 4 and we're going to Section C today. We've been working on how to solve quadratic equations. So recall, what makes an equation quadratic? That's right, it has an x squared. We've learned that factoring is the quickest and easiest method to solve a quadratic, but that doesn't always work. Then we learned, well, the opposite of squaring is the square root. So we can use square rooting to solve a quadratic, but we're going to find out today that doesn't always work either. So we're going to our third method, which is called complete the square. So let's go to our class notes. Okay, first we got to go back to definitions from algebra. We got to understand the word perfect square trinomial. Remember, tri means three terms. A perfect square trinomial is a trinomial that will factor into the same two binomials. So if you look at my example, x squared minus 10x plus 25 is a trinomial. If I asked you to factor that and break it down into parentheses, you would get x times x for x squared. You would get 5 times 5 for 25. And to add to make a negative 10x, you'd get a negative 5 and a negative 5. So we know x squared minus 10x plus 25 would factor to be x minus 5 times x minus 5, which we know we could write a better way. We could write that as x minus 5 squared because we're multiplying the same thing. So now that we know what a perfect square trinomial is, let's understand the definition, complete the square. Okay, it's a definition. It says, completing the square means to transform a binomial into a perfect square trinomial. So transform makes me think of the word change, like the Transformers, they change. And what you're going to do is you're going to take a binomial, which we know has 2 terms, and change it into a trinomial, which has 3 terms. Well, guys, there's only one way to do that. Okay? Physically speaking, if I have 2 markers and I want to change this into 3 markers, the only way I can make 2 become 3 is to physically add in my group here another marker. So to do complete the square means to change a bi 2 terms into a tri 3 terms. And the way we do that is we're going to add a number. So that's what your definition says. Now, you just can't add any number. You got to figure out how to get that number. So let's look here. If I give you the binomial x squared plus 6x, it has 2 terms. We want to do complete the square. We want to make this a trinomial that has 3 terms. So we're going to add a number. To add a number, it says you take half the coefficient of x. So what's the coefficient in front of x? 6. We're going to take half of that. Half of 6 is 3. And then we're going to square that. And 3 squared is 9. So to make x squared plus 6x become a perfect square trinomial, we're going to add 9. And if you look, when you get x squared plus 6x plus 9, you now have a trinomial. And yes, that is guaranteed to factor to be exactly alike. So completing the square is really simple. All it means to do is add on a number. But by adding that number, you're making a 3-term trinomial, and you're guaranteeing that it will factor. So what we're going to do here is 4 examples on just understanding how to do complete the square. So let's go to the board. Okay, let's make sure we understand this definition. These are all 2 terms, binomials. I want to make them 3 terms, trinomials. All I'm asking you to do is understand what the word complete the square means. So to get complete the square, we want to add on a missing number. Add on a missing number. That's all we want to do when we say let's complete the square. Now, to do this, the rule is to find this missing number, we take half of the coefficient in front of x. So what's the coefficient in front of x? 10. We're going to take half of 10, which is 5, and then we're going to square that, and we're going to get 25. And now by adding on the 25, you made a trinomial. What makes that special is it's guaranteed to factor. Let's do the next one. What are we going to take half of? Negative 16. So half of negative 16 is negative 8. And then we're going to square it, and we're going to get 64. And we all know when we square a negative, it always becomes positive. That's why we're always adding here. What you've done now is make a trinomial. This is guaranteed to factor. X squared is x times x. 64 is 8 times 8. And yes, 8 and 8 will add to 16. All right, let's do the third one. I want to complete the square. What are we taking half of? The coefficient in front is the invisible number 1. So we're taking half of 1, which is a half. Now, do not make decimals. As you can see so far, I have avoided decimals as much as possible. The same thing's true with completing the square. If it doesn't divide evenly, if you cannot take half of it nicely, leave it as a fraction. And then we're going to square this, because we can square fractions in our head. Squaring is just multiplying, and multiplying fractions is no problem. Top times top, bottom times bottom. A half times a half is 1 times 1 is 1, and 2 times 2 is 4. So the missing number here would be 1/4. Now you're going to say, Miss Black, that doesn't factor. Sure it does. What multiplies to x squared? X times x. What multiplies to 1/4? 1 over 2 and 1 over 2. A half and a half will add to 1. So it does factor. Okay, let's do our last one, making sure we understand how to complete the square. So the rule is we're going to take half of the coefficient. This time the coefficient is negative a half. Well, half of negative a half is negative 1/4. Top times top, bottom times bottom. Then we got to square that. Negative 1 times negative 1 is 1. 4 times 4 is 16. Now I know you're saying half of a half is a fourth. Sure it is. If you had half of something, like say half a dollar, that would be 50 cents. And if I took another half of that, half of 50 cents would be a quarter. So that makes sense. And then we square that, we get the 1/16. Now all we've learned to do is complete the square. Have we done any solving yet? No. These aren't even equations. Why are these not equations? Because there's no equal sign. So now we're going to go into the mode. How do you use this completing the square? How do you use this idea of finding this missing number to solve a quadratic equation? Let's look at the notes at the procedure. All right. Now, I'm going to be honest with you guys. This is not my favorite way to solve a quadratic. Because if you look at the procedure up here, there are 6 steps you have to go through. Factoring and square rooting only had 4 steps, which is not that bad to memorize. But to solve a quadratic equation, by doing complete the square, you got to go through these 6 steps. So let's read through. Step 1 says, make sure your x squared has a coefficient of 1. We got to guarantee that. Then it says, step 2, move the constant to the right. Step 3 says, complete the square. That's what we just learned how to do. That's where we're going to add that new number in. After you add that new number in, everything else makes sense. When you add that number in, you're making a trinomial. Well, that trinomial now is going to, step 4, factor. And because it's going to factor to be exactly alike, we're going to write it as a square, which means then we could do step 5, we could square root it, and then solve for x. So the steps are not hard. It's just memorizing the order. So we're going to go to our, I believe we have 2 examples here. And we're going to go to our first example on the board, and we're going to go through this procedure slowly. So let's take our equation. X squared minus 8x minus 11 equals 0. Okay, this is what I want you all to understand. If I just put that equation on the board and said solve it, first thing I would expect you all to say is, okay, it's quadratic. Miss Black, it has an x squared. Great. We now have 3 different methods to solve. We could see if it factored. So if we were thinking about factoring, we'd have to go on our brain and think, what's the process? Factoring means to set it equal to 0. It's done. Factoring means to figure out what rule. Is it a GCF? No, there's nothing in common we can divide by. Is it difference of perfect squares? No, it's not a binomial. Is it factoring the trinomial rule? Well, yeah, there's 3 terms, but watch what happens if you try to factor. The first term would be x times x. The last term is 11. The only thing that multiplies to 11 is 11 and 1. But remember, it's got to multiply to this, and it's got to now subtract to what's in the middle. Will 11 and 1 subtract to 8? No. So here's an example of a quadratic equation that will not factor. So then you would say, okay, let's do the square root method that we learned in Module 4b. Well, to do the square root method, the procedure is totally different. The square root method said isolate the square. Who owns the square? Right there. So you'd isolate it. You'd move the 8x over by adding and the 11 over by adding. Okay? So if I follow my procedures, that's how we do the square root method. We move everything over to the right that doesn't have the square. Then we square root both sides. Well, we know squares and square roots cancel. That's nice. But people, can you square root 8x plus 11? The only thing you guys can square root is a number. So that's not going to work. So now we're stuck because we've learned how to factor in square root and neither method work. So here's an example of a quadratic equation we're going to have to solve doing this new method, complete the square. So we have 6 steps. We're going to go through them. Step 1 is make sure the x squared has a coefficient of 1. It does. So step 1's already done. Step 2, move the constant to the right side. Who's the constant? It's the 11. So we're going to add it. So here goes step 2. Move the constant. The reason why you're moving it is you need a binomial to start with. Now that you have a binomial, step 3 is complete the square. And that's what you just learned how to do. Completing the square means to add a number. How do you get that number? You take half the coefficient in front of x. So we're going to take half of negative 8, which is negative 4, and we're going to square that and get 16. So we're going to physically add 16. But here's the problem. An equal sign on an equation separates the left side and the right side. And we've already discussed this. If you're lifting weights and you add 16 pounds on one side to balance, you got to add it on the other. So guys, if you add the 16 on the left, you got to add it on the right. But that's what step 3 is. You get that binomial, you find that missing number. You add it on, you make a trinomial. If you add the number to the left, you add it to the right to keep balance. Now, what was the purpose of adding this number? Now that you made this trinomial, it's guaranteed to factor. So that's step 4. X squared is x times x. What multiplies to 16 and adds to negative 8? That's negative 4 times negative 4. On the right side, 11 plus 16 is 27. Now, if you look closely, every time you add this missing number on and complete the square, you're going to get a trinomial that will factor to be exactly alike. That's our definition, perfect square. And because this is a perfect square, we could write this how many times? We could write it like this to say twice, x plus 4 squared. And if we write it as a square, now we can do step 5, which we learned the opposite of squaring is square rooting. Squares and square roots cancel out. There's your x minus 4. You learned when you square root, you put both a plus or minus, square root 27. So what you're really doing is incorporating factoring and square rooting in this method. Now we've learned you can't leave the square root of 27. What perfect square isn't it? That's right, it's 9 and 3. It's positive, so it's not going to be imaginary, people. So now we have x minus 4 equals plus or minus. The square root of 9 is 3. The square root of 3 you can't do anything with. But we're not done. Step 6 is still to get x by itself. Remember, your goal in this whole chapter when solving is to get x isolated. So let's go over here to do step 6, which would be x minus 4 equals 3 square roots of 3. X minus 4 equals negative 3 square roots of 3. Okay? Plus or minus means there's got to be 2 equations. So now we'll isolate by adding 4. We've discussed this in algebra. 4 is a whole number. 3 square roots of 3 is an irrational number. You can't add them together. So the whole number goes in the front. The irrational number goes in the back. And we'll do the same thing here. The whole number is 4 minus the irrational number 3 square root of 3. And we have 2 solutions. I'll be honest with you, I'm not a fan of this procedure because it's long and cumbersome. But if you're good at memorizing steps, it makes sense. To do the complete the square method, you want to start with a binomial. That's why we move the constant over. We get our binomial, we add on our missing number. That's going to guarantee us to factor, to be exactly alike. That's why we're going to do the opposite of squaring, square rooting, and get our 2 solutions. Okay, we have one more example to try. I know it's a lot, but if you follow the procedure step by step, you should get your solution. All right, our last equation today is 2x squared minus 20x minus 2 equals 0. So again, we're going to go through the steps slowly. There are 6 steps to completing the square method. I know I want to solve this. It's an equation. Equation means I want to get x by itself. Because this is quadratic, I have lots of options. It's already set equal to 0. I could try to factor it. I could try the square root method. But I'm telling you that neither one are going to work. If you try to factor this, you're not going to get it to factor. If you try to do the square root method, it's not going to work because to isolate this square, you're going to move everything else over. So the easiest way to do this one is by completing the square. So let's go through the steps. Step 1 means your x squared has to have a coefficient of 1. Is that a 1? Nope, it's a 2. All right, we're going to use arithmetic skills. How do this 2 connected? It's connected by multiplication. How do we make it become a 1? We do division. But if we divide that term by 2, we have to divide everybody by 2. So step 1, you got to start out with an x squared. So we're going to get the 2 out of there. That's going to become a minus 10x minus 1 equals 0. Okay? Now, step 2 is, I don't want a trinomial, I want a binomial. So I move my constant. X squared minus 10x equals 1. You want a binomial, so now you could do complete the square. Complete the square is just meaning to add on that new number. How do you get that new number? You learn the rule. The rule to complete the square is to take half of negative 10, that's in front of the x, which would be negative 5, and square it. So what number are we going to add on? 25. We'll add 25. We'll add 25. That's step 3. It makes sense now. Once this is a trinomial, it's guaranteed to factor. X times x is x squared. 5 times 5 is 25, and we're going to add to a negative, so they're both going to be negative. On this side, 1 and 25 is 26. Because this is guaranteed to factor to be the same binomial, we write it as a square. And if we write it as a square, now we can do step 5. So step 4 is factoring. Step 5 is, if it's written as a square, we could do the square root method. Squares and square roots cancel out. There's your x minus 5. Because you have a square root, you're going to put your plus or minus. Now we have a square root of 26. Can that break down? No, 26 is not a perfect square. And 4 or 9 or 16 or 25 does not divide into that. That are perfect squares. So that's in lowest terms. But you're not done. X is not by itself. How many answers are going to be here? 2. It's quadratic, always 2. So we're going to write our 2 equations. We're going to have x minus 5 equals positive square root of 26. X minus 5 equals negative square root of 26. And this is step 6. And now you'll add your 5. You can't add a whole number to a square root, so the whole number goes in front. There's your first solution. We're going to add our 5. You can't add a whole number 5 to a negative square root, so the whole number goes in front. And there's your second solution. Okay, so what you've seen today is a third method to solve quadratics. Yes, there's 6 steps. Yes, you have to have them memorized. But if you follow the procedure correctly, you can always reach a solution. I'll catch you in the next module.